plus 5 times 2 squared, plus 5 times 3 squared, plus 5 times 4 squared. I should have picked a small number. Plus 5 times 5 squared, plus 5 times 6 squared.
Depending what number n is, you could.
So every one of the add-ins has what on it?
5. 5.
And since you know about factoring, you should be able to remember the 5. You should be able to take it out. Right? So to C, whatever multiplicative constants come to the outside of sigma notation. So C sum AN. So now you can figure this out a little more easily. You don't have to worry about the 5. And I have a rule for n squared, right? And a rule for the squares. So for this problem, if I had to figure out what this was, I would say this is the same as 5 times the sum of n squared. N goes from 1 to 45, and that has a formula for it. So this is really 5 times my formula, which in this case would be what? 45, 46, 91, 6. Would we agree? Following the middle formula, right? Following that formula right there, where n is 45. Right? Make sense?
Wait, okay, so how did you get 45, 46, and 49 again?
I plugged the 45, the uppermost value, the last value that you're going to input into this thing, into this formula here. And those are those 3 top numbers by chance.
Shouldn't be 93. Okay.
What's that?
Is that a plus 1, 2 and a plus 1?
Yeah, 2 and plus 1.
Is that a 40?
Is this 93?
Yeah.
I was trying to write 91. It looks like a 3.
I mean, should it be 93?
Should this be 93? This is a 5.
Oh, it's fine. Never mind.
Yeah, use the 45, not the previous one.
Yes.
I hear it. Okay. Yeah, don't use the previous one. All right. So that's how you handle that problem. Now, you have to remember also that 6. If you're going to do this computation in your head, which I think is a good idea, 6 does divide this evenly. It has to, because you're adding up a bunch of integers. It can't be. You can't add a bunch of integers to get a fraction, right? That means this 6 always divides the numerator. Maybe not specifically one of these factors, but somehow the 2 from the 6 goes into one of these, and the 3 from the 6 goes into one of these somehow. Always. Right? Okay. 6 going into one of these perfectly? No. What? But 3 goes into 45 and 2 goes into 46, so you see it would be eliminated, and then you can just multiply more easily. All right. Property 2. If you have an expression inside the sigma notation, which is a sum and or difference, doesn't matter, then since the sigma itself is adding, so I'm adding up a bunch of things which are additive, right, throughout this process. So the way I group them together is my choice. So I'm going to take all the ANs, and I'll add them up, and then I'm going to take all the BNs, and I'll add them up, and then I'll do that final add or subtract I need to do between the two. Okay? So you could say the sigma notation is distributive in some sense. You don't usually use that word except for when you're dealing with numbers. You don't use it for operations, but that's kind of what it looks like, right? It looks like it's distributive. So if you had the expression n squared plus 3n, n equals, I don't know, 1, 2, 6. How will you simplify this problem? You apply these first 2 properties. And we'll write the sum of n squared plus 3 times the sum of n as n ranges from 1 to 6. The sum of n squared from 1 to 6, you could compute it by hand. It's not that many numbers to figure out. But again, the formula is probably faster. You just start using it. So we'd have 6 times 7 times what? 13. And divided by the 6 is really 7 times 13. That's 91. Okay? So this one's 91. And this one over here is just what? 6 times 10 divided by 2, which is 21. Okay. So plus 3 times 21. And so whatever that is. 1 plus 63, 154. See the basic idea, yeah? any questions about sigma notation? We're now going to do the actual main idea of this section. This is just notation. You guys okay with it? Here we go.